To determine the correct transformer size for powering 7 construction trailers, a series of calculations must be performed. Firstly, calculate the total volt-amps required by the trailers. Each trailer is assumed to draw 50 amps at 240 volts single phase. Therefore, the volt-ampere requirement for a single trailer is 50 amps multiplied by 240 volts, which equals 12,000 volt-amps. With 7 trailers, the total volt-amps is 7 multiplied by 12,000 volt-amps, equaling 84,000 volt-amps. Secondly, consider the power factor. The power factor represents the ratio of real power to apparent power and is typically less than 1 due to inductive loads. For construction equipment, a power factor of 0.85 is commonly used. To account for the power factor, divide the total volt-amps by the power factor. In this case, 84,000 volt-amps divided by 0.85 equals 98,823 volt-amps. Thirdly, determine if a 45 kVA transformer is adequate. A 45 kVA transformer is rated for 45,000 volt-amps. Comparing this to the calculated load of 98,823 volt-amps, it is clear that a 45 kVA transformer is insufficient. The load significantly exceeds the transformer's capacity. To determine the minimum acceptable transformer size, a safety factor should be included. A safety factor accounts for potential increases in load and ensures the transformer is not operating at its maximum capacity continuously, which can reduce its lifespan. A common safety factor is 1.5. Multiply the adjusted load by the safety factor. In this scenario, 98,823 volt-amps multiplied by 1.5 equals 148,235 volt-amps. Therefore, the transformer should be sized to handle at least 148,235 volt-amps. The nearest standard transformer size that meets or exceeds this requirement is 150 kVA. The primary voltage is specified as 600 volts 3-phase. This is a common primary voltage for transformers used in construction applications. In conclusion, based on these calculations, a 150 kVA transformer with a 600 volts 3-phase primary voltage is required to provide sufficient power for the 7 construction trailers. Using a smaller transformer would likely result in overloading, overheating, and potential equipment failure. Therefore, ensure the transformer is adequately sized to meet the demands of the load, taking into account the power factor and a suitable safety factor. The process includes several steps. 1. Determining the individual trailer load in volt-amps. 2. Multiplying by the number of trailers to get the total volt-amps. 3. Dividing the total volt-amps by the power factor to get the adjusted volt-amps. 4. Multiplying the adjusted volt-amps by a safety factor. 5. Selecting a standard transformer size that meets or exceeds the final volt-ampere requirement. This ensures reliable and safe operation of the construction trailers. When calculating transformer sizes, it's also important to consider future expansion or changes in load requirements. If there's a possibility of adding more trailers or equipment in the future, it's wise to select a transformer with even more capacity to avoid the need for a costly upgrade later on. Additionally, the location of the transformer should be considered. Ensure that the transformer is placed in a well-ventilated area to prevent overheating and that it is protected from the elements and physical damage. Regular maintenance of the transformer is also essential to ensure its continued reliable operation. This includes inspecting the transformer for any signs of damage or wear, checking the oil level if applicable, and ensuring that the connections are tight and corrosion-free. Following these guidelines will help ensure that the transformer provides a safe and reliable power supply for the construction trailers. Consider voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, it's important to select conductors of the appropriate size for the load and distance. The National Electrical Code (NEC) provides tables and guidelines for determining the appropriate conductor size based on the current, voltage, and distance. For example, NEC Table 3.10.15 details ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius in various conditions. When selecting conductors for the construction trailers, it's also important to consider the environmental conditions, such as temperature and moisture. Conductors that are exposed to high temperatures or moisture may need to be deaerated to prevent overheating and ensure their long-term reliability. Additionally, it's important to ensure that all electrical connections are properly made and tightened to minimize the risk of loose connections and arcing. Loose connections can cause excessive heat and potentially lead to fires. Therefore, regular inspections of electrical connections are essential to ensure their integrity. Another important consideration is grounding. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The NEC requires that all electrical equipment be properly grounded, and it provides detailed guidelines for grounding systems. When setting up the electrical system for the construction trailers, it's important to ensure that the grounding system is properly installed and maintained. This includes grounding the transformer, the trailers, and all electrical equipment within the trailers. Grounding electrodes, such as ground rods, should be installed in accordance with the NEC and should be tested regularly to ensure their effectiveness. Surge protection is also an important consideration, especially in areas that are prone to lightning strikes or other electrical surges. Surge protective devices, SPDs, can help to protect electrical equipment from damage caused by surges. SPD should be installed at the main electrical panel and at any sensitive equipment such as computers or electronic devices. The selection of SPD should be based on the voltage, current, and surge capacity requirements of the equipment being protected. Coordination of overcurrent protective devices such as circuit breakers and fuses is also essential to ensure that the electrical system is properly protected. Overcurrent protective devices are designed to interrupt the flow of current in the event of an overload or short circuit. It's important to select overcurrent protective devices that are properly sized for the conductors and equipment they are protecting and that are coordinated to minimize the extent of any outages. Coordination studies can be performed to determine the appropriate settings for overcurrent protective devices to ensure that they operate correctly in the event of a fault. Arc flash hazard analysis is another important consideration for electrical safety. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flash can cause serious burns, injuries, and even death. An arc flash hazard analysis should be performed to determine the potential arc flash hazards in the electrical system and to identify appropriate safety measures to protect workers from these hazards. Safety measures may include wearing appropriate personal protective equipment, PPE, such as arc-rated clothing and gloves, and implementing safe work practices, such as de-energizing equipment before working on it. The NEC provides guidelines for arc flash hazard analysis and safety measures. Electrical safety training is also essential for all workers who may be exposed to electrical hazards. Workers should be trained on the hazards of electricity, safe work practices, and the proper use of PPE. Training should be conducted regularly and should be tailored to the specific tasks and hazards that workers may encounter. Qualified electrical workers should be used to perform electrical work. They must have the skills and knowledge to perform the work safely and in accordance with applicable codes and standards. Unqualified workers should not perform electrical work, and they should be supervised by qualified workers. Permits and inspections may be required for electrical work, depending on the local jurisdiction. It's important to check with the local authorities to determine the permit and inspection requirements before starting any electrical work. Inspections are conducted to ensure that the electrical work is performed in accordance with applicable codes and standards and that the electrical system is safe to operate. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years and is widely adopted by jurisdictions throughout the United States. It is important to be familiar with the NEC and to follow its guidelines when performing electrical work. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. By following the NEC, you can help to ensure that electrical installations are safe and reliable. Additionally, there are other standards and guidelines that may be applicable to electrical installations depending on the specific application and location. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers, i.e., the National Fire Protection Association, NFPA, and the American National Standards Institute, ANSI. It's important to be aware of these standards and guidelines and to follow them when performing electrical work. Finally, it's important to document all electrical work that is performed. This includes creating drawings, specifications, and test reports. Documentation can be helpful for future maintenance and troubleshooting, and it can also be required by regulatory agencies. The documentation should be accurate and complete, and it should be stored in a safe and accessible location. By following these guidelines, you can help to ensure that the electrical system for the construction trailers is safe, reliable, and compliant with applicable codes and standards. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary skills, knowledge, and training. If you are not qualified to perform electrical work, it is best to hire a licensed electrician to do the work for you. Engaging a licensed electrician brings expertise, code compliance, safety, and liability protection. Firstly, licensed electricians possess the knowledge and skills acquired through extensive training and experience. They are well versed in electrical codes, safety regulations, and best practices. Secondly, licensed electricians ensure that all electrical work complies with local and national electrical codes. This compliance is essential for safety and can prevent potential hazards and violations. Thirdly, licensed electricians prioritize safety in every aspect of their work. They are trained to identify and mitigate electrical hazards, protecting both themselves and the property owners. Fourthly, engaging a licensed electrician provides liability protection. If any electrical issues arise due to faulty workmanship, the electrician's insurance covers the damages, safeguarding the property owner from financial liabilities. Proper conductor sizing is crucial for safety and efficiency. Undersized conductors can overheat, leading to insulation damage, fire hazards, and voltage drop, which can cause equipment malfunction. Oversized conductors increase material costs and may be difficult to terminate properly. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. The National Electrical Code, NEC, provides tables that list the ampacities of various conductor sizes and types, based on their insulation temperature rating and installation conditions. The most commonly used ampacity tables are found in NEC section 3.1015, and these tables provide ampacity values for conductors in various raceways and direct burial applications. To determine the appropriate conductor size, first calculate the load current. For continuous loads, which are loads that operate for 3 IOs or more, the NEC requires that the conductor be sized to carry at least 125% of the continuous load current. This is to account for the additional heating that can occur when a load operates continuously. Next, select a conductor with an ampacity that is equal to or greater than the calculated load current. Be sure to consider the temperature rating of the conductor and any applicable derating factors. Derating factors are used to reduce the ampacity of a conductor when it is installed in conditions that can increase its temperature, such as high ambient temperatures, multiple conductors in a raceway, or direct sunlight exposure. The NEC provides tables that list derating factors for various conditions. Once you have selected a conductor size, verify that it is protected by an overcurrent protective device, such as a circuit breaker or fuse, that is sized appropriately for the conductor's ampacity. The overcurrent protective device should trip or blow before the conductor can overheat and cause a fire. Voltage drop is the reduction in voltage that occurs along a conductor due to its impedance. Excessive voltage drop can cause equipment to operate inefficiently or malfunction. The NEC recommends that voltage drop be limited to 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use the following formula: voltage drop equals 2 multiplied by the length of the conductor in feet multiplied by the current in ounce multiplied by the impedance of the conductor in ohms per foot divided by 1000. The impedance of the conductor can be obtained from conductor manufacturer's data or from NEC tables. If the calculated voltage drop exceeds the recommended limits, you will need to increase the conductor size or reduce the length of the conductor. Conduit fill refers to the percentage of the cross-sectional area of a conduit that is occupied by conductors. The NEC limits the maximum conduit fill to prevent overheating and to allow for easy pulling of conductors. The maximum allowable conduit fill varies depending on the type of conduit and the number of conductors. The NEC provides tables that list the maximum allowable conduit fill for various types of conduit and conductors. When calculating conduit fill, be sure to include all conductors in the conduit, including equipment grounding conductors. Proper conduit fill ensures adequate ventilation and prevents damage to conductors during installation and operation. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. Bonding connects all metal parts of an electrical system together, which helps to equalize their potential and prevent voltage differences that can cause shock hazards. The NEC requires that all electrical equipment be properly grounded and bonded. The grounding system should be designed to provide a lower impedance path for fault current to flow back to the source. This can be achieved by using grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes. The bonding system should connect all metal parts of the electrical system together, including equipment enclosures, raceways, and metal piping. This can be achieved by using bonding jumpers, which are short lengths of conductor that are used to connect metal parts together. Surge protection is important for protecting electrical equipment from voltage surges caused by lightning, utility switching, or other events. Surge protective devices, SPDs, are designed to divert surge current away from sensitive equipment, protecting it from damage. SPD should be installed at the main electrical panel and at any sensitive equipment, such as computers or electronic devices. The selection of SPD should be based on the voltage current and surge capacity requirements of the equipment being protected. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flash can cause serious burns, injuries, and even death. An arc flash hazard analysis should be performed to determine the potential arc flash hazards in the electrical system and to identify appropriate safety measures to protect workers from these hazards. Safety measures may include wearing appropriate personal protective equipment, PPE, such as arc-rated clothing and gloves, and implementing safe work practices, such as de-energizing equipment before working on it. The NEC provides guidelines for arc flash hazard analysis and safety measures. Electrical safety training is essential for all workers who may be exposed to electrical hazards. Workers should be trained on the hazards of electricity, safe work practices, and the proper use of PPE. Training should be conducted regularly and should be tailored to the specific tasks and hazards that workers may encounter. The electrical installation must comply with the National Electrical Code, NEC, and local regulations. This includes obtaining necessary permits and inspections. Adhering to these regulations ensures the safety and legality of the installation. Neglecting code compliance can result in fines, safety hazards, and potential legal issues. Always consult with local authorities to determine the specific requirements for your area. The NEC provides comprehensive guidelines for electrical installations. Staying updated with the latest edition of the NEC is essential for compliance. Regular inspections ensure the electrical system remains safe and code compliant. Addressing any identified issues promptly prevents potential problems. Properly sized and installed conductors minimize voltage drop. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the impedance of the conductors. Excessive voltage drop can cause equipment to operate inefficiently or malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, use conductors with adequate ampacity and consider shortening the conductor length. Conduit fill refers to the percentage of the cross-sectional area of a conduit occupied by conductors. The NEC sets limits on conduit fill to prevent overheating and ensure conductors can be easily pulled. Overfilling conduits can damage conductors and reduce their ampacity. Refer to the NEC for specific conduit fill requirements based on conduit type and conductor size. Grounding provides a path for fault current to return to the source, protecting against electrical shock. Bonding connects metal parts to create an electrically conductive path, minimizing voltage differences. The NEC provides detailed requirements for grounding and bonding systems. Proper grounding and bonding are essential for safety. Surge protection safeguards electrical equipment from voltage surges caused by lightning or other events. Surge protective devices, SPDs, divert excess voltage away from sensitive equipment. SPD should be installed at the main electrical panel and at critical equipment locations. Select SPD with appropriate voltage and current ratings. Arc flash is a dangerous phenomenon that can occur during electrical faults. Arc flash produces intense heat and pressure, posing significant risks to workers. An arc flash hazard analysis assesses the potential hazards and determines appropriate safety measures. Personal protective equipment, PPE, such as arc-rated clothing and face shields, protects workers from arc flash hazards. Safe work practices, such as the energizing equipment before working on it, minimize the risk of arc flash incident. Electrical safety training equips workers with the knowledge and skills to work safely with electricity. Training should cover electrical hazards, safe work practices, and the use of PPE. Regular training updates ensure workers stay informed about the latest safety procedures. Qualified electrical workers possess the skills and knowledge to perform electrical work safely and effectively. Using qualified workers ensures that the electrical installation is done correctly and complies with regulations. Check the credentials and experience of electrical workers before hiring them. Permits and inspections ensure that electrical work meets safety standards and complies with regulations. Obtain necessary permits before starting any electrical work. Inspections verify that the installation meets code requirements and is safe to operate. The NEC is a comprehensive set of standards for electrical installations. Staying updated with the latest edition of the NEC is essential for compliance. Consult the NEC for specific requirements related to wiring methods, grounding, overcurrent protection, and equipment installation. These standards and guidelines are crucial for ensuring electrical safety and compliance. They provide detailed information on various aspects of electrical installations, helping to minimize risks and maintain reliable performance. Regularly review and update your knowledge of these standards to stay informed and ensure adherence. Documenting all electrical work provides a record of the installation, facilitating future maintenance and troubleshooting. Create detailed drawings, specifications, and test reports. Store documentation in a safe and accessible location. Accurate documentation is essential for long-term management of the electrical system. By following these guidelines, you can ensure that the electrical system for your construction trailers is safe, reliable, and compliant with applicable codes and standards. This comprehensive approach minimizes risks and ensures the well-being of workers and the longevity of the electrical installation. The process requires a thorough understanding of electrical principles, codes, and safety practices. It is essential to consult with qualified professionals and stay informed about the latest regulations and technologies. Proper planning, execution, and maintenance are key to ensuring a safe and efficient electrical system.